Three objectives to cover this week. The first one is I want everybody to understand the limits of short-term memory. The second is I want everybody to understand the role of pre-attentive attributes. And third, everybody needs to understand the role of Gestalt principles. So we're going to break this down now. Short-term memory. Let's talk a little bit about the human brain before we begin. The brain is basically a very good computer system. You could probably say it was probably the first computer system that's out there. A computer functions a lot like the human brain in that it has input devices and output devices and storage devices. For the human brain, our input devices are senses, so your sight, your hearing, your touch, and your taste. The computer has keyboards, mouse, scanner, etc. They both also have output devices, but what we're going to focus on really is going to be those storage devices, because the storage devices is what we're going to try to make the most of when we're doing our visualization, particularly the short-term storage devices. So in a computer, you have short-term RAM and long-term storage. The human brain has long-term memory, but it also has two types of short-term memory. It has iconic and working memory. And why it is so important that we need to focus on iconic memory and working memory is because we want the user to get to insight as quickly as possible. And if you remember from Module 1, we talked about that. Why is visualization so important nowadays is because there's so much data out there. We have to help our users come to a decision or come to a conclusion as quickly as possible, which is why short-term memory is so important to tap into. So let's break these down a little bit. Let's talk about the differences between iconic memory, working memory, and long-term memory, and why each one is important to remember. So iconic memory is automatic and unconscious. You don't think about it. It's there just a few seconds before it moves on to short-term memory or it leaves the brain completely. A good example of this is if you enter a really dark room and turn on a light and then the light bulb breaks and then it goes dark again. That brief memory of what you saw in the room before the lights went back out is what's stored in your iconic memory. And this is called pre-attentive processing. So remember that, because we're going to talk about the pre-attentive attributes. Those are the things that are going to tap into your iconic memory. So let's talk next about working or short-term memory. This is temporary and limited. It's a little more long-lasting than iconic memory. It typically lasts a few seconds to a few hours before either moving on to long-term memory or totally going away. Good example of this is cramming for exams. You can spend, a whole night cramming for an exam for the next day, and you might remember it for the exam, but a week, maybe 2 weeks later, you're going to have a hard time remembering everything that you crammed into your brain. For things to move on to long-term memory, you typically have to make sure that they're repeated over and over and over again. That's why when you learn a software program like Tableau, for instance, you have to keep practicing it. Or if you're learning a musical instrument, you have to keep practicing it, because the practice is what moves things from short-term memory to long-term memory. Now, with short-term memory, we do use a lot of short-term memory processes when we do our visualizations, but you have to keep a few things in mind. The most important thing to keep in mind is that the brain can only process 3 to 4 chunks of information at a time, and it can only store that amount at a time in your short-term memory. So how does this come into play with visualizations? I'll give you an example. So here you can see a scatter plot. On the right-hand side is your legend. Now notice there's probably close to 40 different countries represented by a certain color in that legend. And if you use that sort of legend, you're forcing your user to have to go back and forth between the scatter plot and the legend to try to figure out, okay, now which color is that pink dot representing? And the user just has to keep going back and forth to try to understand the visualization. With something like this, you're probably just better off using a table, because then a table can the table uses the verbal processing systems of the brain, not the visual processing systems. So it would probably be easier for your user to actually see a table of this data instead of this visual representation. Now let's wrap it up and talk about long-term memory. Now long-term memory, like I said, with enough rehearsal, information will move to long-term memory. Now we don't really want to tap into long-term memory when we're doing our visualizations. The reason is because rehearsal and the process of moving information to long-term memory is a lot more intense, and you want your user to be able to reserve that processing for things like decision making, goal setting, things like that, that you really want your user to be able to focus on. You just want to give your user the quick, easy things that they can see, that they can use to apply to their long-term memory processes. Okay, I said we were going to talk about pre-attentive attributes. So I know Stephen Few went through the pre-attentive attributes in your reading, so you should be familiar with that terminology. But remember, pre-attentive attributes are what are the things that we utilize to take advantage of pre-attentive processing of the brain, or that iconic memory processes. So here are all of the pre-attentive attributes. And there are a lot more that are represented here than in the Stephen Few book. I believe Stephen Few only has like 6 of the form attributes, and maybe only 1 position, and I think he even leaves off motion. So we're probably going to stick with Stephen Few's list, but I do want you guys to be aware of the of all of the pre-attentive attributes that you can use. So we're going to go through these one by one, and I'm going to give you an example of each one so you have a good idea of in what capacity you can use these. So the first one we're going to look at is length. Now, this is a bar chart. Bar charts primarily use length as their pre-attentive attribute. And why is that? Well, it's so easy to see that there are many more students using the excuse of, I forgot to set my alarm, than the excuse, it was still too dark, I thought it was nighttime. All you have to do, all your brain has to do, is look at the length of those bars, and they can make a really easy comparison between all the different categories of excuses. So length is a really powerful pre-attentive attribute, and it's the one that's used primarily for bar charts. Now here's a bar chart that is also using width, and width is not used quite as much. One of the reasons is it's just harder for the human brain to quantify the differences in width. But occasionally you'll see something like this. You'll see a bar chart where obviously this still uses length, because length, you can tell that between the different months that the actual value of February is much more than the actual value of January. And similarly, the planned value of March is much more than the planned value of January. So the length, it's using length that way, but it's also using width to represent the differences between the categories of plan and actual. Now, if you're really in tune to this, you'll also see that there's one other attribute that's being used here, and that's the attribute of color. So plan and actual, those two categories are represented by two pre-attentive attributes, width and color. And sometimes you might want to do something like this if you really want something to stand out in one of your visualizations. Okay, let's talk about orientation. Orientation is also slope, and line graphs are, they use primarily orientation. And what makes these work is that in a line graph, in this line graph in particular, you can tell that the population of bears is increasing because the line is going from the lower left to the upper right. Well, you compare that to the population of dolphins, you know that that is decreasing because the line is going from the upper left down to the lower right. So that is another powerful pre-attentive attribute to use, and it's primarily used in line graphs. Now this example uses shape, and shapes are often used when color isn't an option. In this case, this visualization uses both color and shape. So cars are represented by a blue line and a diamond, whereas trucks are represented by a dashed line and a square, a red dashed line and a square. So actually there's several things going on here, but shape is sometimes used if color isn't an option. Back in the days when people were just using Excel to do their visualizations, they didn't have access to color printing. Frequently you would see people using shapes instead of color to represent an attribute. Now, you might also see shapes used in addition to color when you have a whole bunch of different attributes that you need to represent. And we'll talk a lot about that when we get into mapping, because sometimes we want to represent a lot of different things when we're doing spatial graphs, and sometimes we have to use shape in addition to color and size to do that. Speaking of maps, this is an example of size. So you can see that the size of the circle in California is much greater than the size of the circle in Iowa. It's very easy to know that. There are some limitations with size, however, because you really can't tell how much greater that circle in California is compared to the circle in Iowa. That your brain has a hard time processing that. So it's not perfect, but it is frequently used when you do spatial graphing like this. And this is an example of enclosure. So you can see in this one how the total night stay on your x-axis is divided up into different categories. So it's divided up in between the loyalty program levels. So silver, you have all your data points enclosed between 5 total night stay and 10 total night stay. And then gold are all the data points between 10 night stays and 25 night stayed. And then platinum is everything over 25. So that's a way of categorizing different data points. Okay, now we're going to talk about color. This is an example of hue, or hues, just, different colors. Hue is probably next to length is and 2D position is probably the most frequently used pre-attentive attribute. So, and in this case, in comparison to the other chart that we saw that used color, only has 4 different regions represented. So it's chunked into smaller amounts that the brain, it's much easier for the brain to process this. Now there's also color intensity. And color intensity, you can also say that could be shading or opacity. This is also has some limitations, simply because I can't tell exactly how much greater California is compared to New York. I can tell it's darker, so it obviously has more sales, but I don't know how much more sales than New York. So there are some limitations with that. Also keep in mind that you can use intensity without any color. You can just use black and white. So you can use a grayscale to represent something with intensity. Okay, spatial positioning. 2D positions. This is another powerful pre-attentive attribute used primarily in scatter plots. Keep in mind this is where you have 2 point values that are represented by a point where those values are mapped on the X and Y axis. So you can see that the first point that has a 0 on the x-axis and maybe a 25 on the y-axis, and then you see the point next to it which has a 4 on the x-axis and maybe a 26 on the y-axis, and so on and so forth. So you can, the brain is, it's really easy for the brain to tell what those values are based on where they are located in the grid. Okay, now how do you choose which pre-attentive attribute to use? Especially when you're talking about the difference between quantitative data and categorical data. Now we'll get more into the differences between quantitative and categorical data in the next 2 modules, but just for now, just keep in mind that quantitative data is anything you can measure. So it's going to be something like profit, or temperature, or rainfall, or the number of customers, something like that. Whereas categorical data is simply something that you use to categorize your data, or slice and dice. That's terminology that's frequently used with data analysts. Examples of that could be region, department, maybe level, anything like that. So which attributes are best to use for quantitative data and which are best to use for categorical data? So for quantitative data, you're going to use length and 2D position most of the time. You can use width, you can use size, and you can use intensity. However, I did point out that width, size, and intensity have some limitations. So you're primarily going to use length and 2D position with variables that you can measure. With categorical data, you're going to use shape, enclosure, hue, intensity, and 2D position. You probably most frequently use hue or color for categorical data. You can use intensity, but again, remember I told you that there's some limitations with that. So keep all of those things in mind. Let's talk now more about color, because color is frequently overused, it's frequently misused, and it can be actually detrimental to use for your users if they have some sort of color blindness or visual impairment. So we're going to talk about each one of these individually. Let's talk about overuse of color. Okay, so take a look at this graph. And automatically you can tell that there's a lot of color here. And it's really bright and vibrant color. The first thing that Stephen Few is going to tell you is that you should never use bright colors like this in your charts and graphs. You should always use a lighter color palette because they're much easier on the eyes. This is really almost shocking to the eyes to see. So stay away from really bright colors in your graphs. Also be careful about using the color red. Basically, because in Western cultures, red typically represents something that's very bad. So you want to minimally use red. And you want to use it only in times when, let's say, your store or your region is showing a loss of profit. That would be the time when you're going to use red. Or if there's just something that you really want, something bad that you want to highlight, that's when you use red. The other thing to keep in mind here is the data ink ratio. And data ink ratio is a term that was popularized by Ed Tufte. We talked about him in Module 1. Data ink ratio is basically your data ink divided by the total ink in your graph. So data ink is any ink that is used to represent your data. So in this instance, the bars are your data ink. Now you don't necessarily need color in those bars because you have the different lengths and you have 2D position. But we'll give this person the benefit of the doubt and just say their data ink is the color of the bars. The total ink is going to be the color of the bars plus that background color. And it's not even just a standard background color, it's a gradient. So there's a lot of total ink in this graph. Your goal is to get a high data ink ratio. So you want the majority of your ink to be for your data and not for unnecessary things in your graph, which in this case would be that horrific background there. So let's talk about color misuse. Color can be very misleading. You may have seen this example before, but take a look at it and your first impression, which square is the lightest? If you've done this before, you'll know those squares are all the same. The reason the square on the right looks so much lighter is because of the background again. It's a gradient. So it's darker on the right, lighter on the left. So the square on the right appears lighter than the square on the left. So color is relative. It isn't absolute. So if you're trying to encode meaning into color, you have to pay attention to how the viewer is going to perceive that color in context. And my last point about color is I want you guys to keep in mind about color blindness. 1 in 12 men and 1 in 200 women in the world have color blindness. I grabbed that stat from colorblindawareness.org. You need to keep your users in mind because there are so many people that have color blindness. You need to stay away from a red-green diverging palette. And in the early days of data visualization, when it was just taking off with the advent of computers, it was a frequently used color palette, the red-green color palette, to represent KPIs, or KPI stands for key performance indicator. So green generally meant you're reaching your goal, everything's great, keep on going. Yellow, which kind of meant, caution, things don't look so good. But red was what showed your user this is really bad. You are not making your goal. You need to pay attention to this. Well, the problem was when you have so many people with color blindness, they couldn't tell the difference between the colors. So it didn't make any sense to them, didn't tell them anything. So make sure that you stay away from a red-green diverging palette. Tableau automatically in a diverging palette where you're representing, good values versus bad values, automatically uses a orange-blue palette. So your good values instead of green are blue, and your bad values are orange instead of red. And I'm just going to briefly bring up Section 508, mainly because there may be some of you who go to work in the public sector for government or for education. And Section 508 is a part of the Rehabilitation Act that requires electronic technologies that are developed and used by the federal government. They have to be accessible to people with disabilities. So if you're working in a government agency and you're developing dashboards for them and you're using a red-green palette, then you're violating Section 508. And that can be bad news for your organization. So make sure that you keep that in the back of your mind. Okay, final objective. Let's talk about Gestalt principles. These all came from the Gestalt School of Psychology, which dates back to 1912, I think. Gestalt basically means pattern, or the whole is other than the sum of the parts. So there are 6 different Gestalt principles, and we will break each one of these down one by one. And I will give you an example of each, just like I did with the pre-attentive attributes. So proximity is the first one. The principle of proximity, that means elements that are placed closer together are perceived as being related more than those that are spaced farther apart. And here's the example for that. You can see 4 different groups of circles. And you can tell they're in 4 different groups because you have a large group all bunched together on the left, and then you have 3 smaller groups of circles all separated on the right. And it's using the spacing in between the groups to help the brain actually group those circles together. So that's proximity. Similarity means that objects that look similar in shape, size, or color are perceived as being grouped together or related. And here's the example of similarity. And this is using shape. So your circles are all in a group and your triangles are all in a group. And you can your brain's probably already focused on that grouping of circles because they're close together. They already have proximity. So it's adding the proximity with the similarity. So that's why the circles pop out to you more than the triangles do. The next principle is enclosure. So we perceive objects as belonging together when they are enclosed by a boundary. Now we already saw an example of that when we were looking at that loyalty program graph a few slides ago, but here's another example of that. So the circles that are enclosed, the brain thinks that those belong together. Now, this one is a little bit confusing because it actually also uses similarity and uses the similarity of color. So your brain's probably competing a little bit, like which group is most important? Are the groups that are enclosed more important, or are the groups that are different colors more important? So that could be a little bit confusing to your user if you use conflicting Gestalt principles in one graph. Okay, principle of closure. So our minds tend to fill in missing information and ignore gaps to create familiar shapes and images. This is an example of closure, not enclosure, closure. And you're not going to use this one a whole lot in your graphs, but you might. But you can obviously see that this is a soccer ball because your mind just knows that there should be a circle that's enclosing all of those shapes together to form the soccer ball. Okay, the principle of continuity. So this is where we perceive lines as continuous movement in order to minimize abrupt changes. Here's an example of continuity. Your brain is typically is going to see a wavy line and a straight line. Just those two things. Now, if you look at it intensely, you can see that you could actually break it up with 2 half circles facing downward, and then 2 half circles facing upward, and then 2 quarter circles on each end. If you study it long enough, you can see that. But your brain automatically wants to see just the wavy line and the straight line. And finally, the principle of connection. So that means that elements that are connected are perceived as being more related than elements that are not connected. And here's the example of connection. So you can see the objects on the right seem more connected than the objects on the left. This is also using similarity again. It's using the circles and the squares, the shapes, as similarity. So again, your brain might be thinking that the circles belong together and the squares belong together. It's also using a little bit of proximity. You know, the 2 groups are separated. But primarily what's going on here is that continuity between the squares and I'm sorry, I say continuity, is connection between the circles and the squares on the right-hand side. So that is the end of the lecture for this week. Next, after the lecture, I will be giving you guys an overview of the Tableau interface. And get ready to do that. You will need to get a copy of the Global Superstore data. We won't do a whole lot with it. We're just going to get familiar with the interface, but I do want you guys to be able to connect to that data source, and then we'll use that as an example. I can give you a brief overview of what you can do with Tableau and where everything is located, okay? So stay tuned for that, and I will talk to you guys again soon.